So for the next 2 hours plus, we're going to go through diaphragm design using unbonded post-tensioning. And I think this is a very interesting topic. It's probably a little controversial, for lack of a better word, these days because of some recent developments in the code writing committees and different factions. So there's a lot of different opinions on how diaphragms, especially concrete diaphragms, can or should be designed, and especially if you're using an unbonded post-tension system. I think there are some real benefits to using a concrete-specific methodology, and I think you benefit from using post-tensioning for a lot of different reasons. So moving forward in the talk, chapter 12 of our book, which you can see here, is focused on diaphragm designs. And one of the reasons we included it in our book, not that it's terribly related to post-tension concrete, but there's not a lot of documentation on how to design concrete diaphragms. A lot of this stuff was kind of developed in industry, and so we wanted to get it more, better explained, so when you discuss it with other engineers, especially when you're discussing with plan checkers, you have something to kind of reinforce, no pun intended, your point of view on how to do these things. But anyway, if you are interested in further discussions or learning about diaphragm designs beyond what I'm going to talk about, chapter 12 in our book, which you can see here, it's in its 4th edition. I think we're up to 470 pages. I think if we ever do a 5th edition, we'll have to start doing volumes because it's getting a little encyclopedia-ish in size. The first half of the book is the undergraduate course that we use the book for. The book's being used right now at UCLA, Cal Poly SLO, Cal State LA, University of Portland, which I'm not exactly sure how that got set up, but I'll take it. And I think a couple other universities. If you're new to post-tensioning or just can't sleep at night and want a refresher, the first 9 chapters will educate you and may put you to sleep at some point. The other 10 chapters or so are real-world examples, do a lot of pictures, a lot of details, basically how we do what we do in their office, and we basically specialize in post-tension concrete. So effectively, if it's been done, we've documented it. So if that's interest to you, there's numerous buying options through hard copies, PDFs, ebooks, and stuff like that. So the first thing I want to talk about in this whole webinar is this is not a new procedure. I did not invent this. My business partner did not invent this. This was handed down kind of engineer to engineer through industry because, as I mentioned before, there wasn't a whole lot of information about concrete diaphragm designs. So again, I'm not trying to sell you on the latest, slickest widget I just invented. I'm definitely not the author of this methodology. I'm just a recipient and hopefully passing it on to other people. If it makes you feel better, it obviously makes me feel a lot better. This approach, what I'm going to go through, has been used for decades. Again, this is not something we just invented. Millions, if not billions, of square feet of elevated PT slabs. So this is something that has been used 70s, 80s, 90s, and onwards. I use it every day when I'm doing buildings right now. So this is a tried and true methodology. We're not reinventing the wheel. We're just hopefully making the wheel a little bit better. As I mentioned before, this whole methodology is primarily taught in industry. If you work for a company that, especially like my company, that specializes in concrete and then obviously more specializes in post-tensioning, we develop these kind of methodologies to keep our decks as reinforcement free or less as possible for the economy of the structure, obviously, and to get the best performance possible out of a concrete material. The one negative about it being taught in industry is that there really isn't a lot of documentation in concrete textbooks. So most likely, unless you went to a very, specific university, the concrete textbooks that I have in the office do not have anything on diaphragm design, and I also have very specific concrete textbooks about shear walls, moment frames, coupling, ductility, confinement, a whole bunch of wonderfully great complex topics in seismic engineering, but nothing about diaphragm behavior, design, detailing, and stuff like that. So when you are approaching a peer reviewer and or plan checker, and you're showing this methodology, sometimes it's a little hard to convince the people because there's not that much documentation. Now, having said that, there is a diagram example in our book, which basically I'm going to use to a modified version for the rest of this webinar. There also is a diaphragm example that's basically the exact, same concept, but not same example in the PTI manual, the handbook that's coming out with the 7th edition. I know that because I wrote the example. I don't know what chapter it is, but again, it's another kind of piece of the puzzle of making this procedure much more, let's say, legitimate in terms of the academic world or the code writing world. The recent development in terms of ACI was Chapter 12 was added in. The section in Chapter 12 did not occur in previous editions. Now, I'm sure all of you know that the whole bookkeeping procedure of ACI was modified between 318.11 and 318.14, and chapters were readjusted and all that kind of stuff, and sections changed. I don't think there was a lot of whole new information being conveyed. It was just put in different locations just to make our lives a little more challenging.